Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 306. It's a medium level problem. The problem name is construct smallest number from di string. So you are given a zero indexed string pattern of length n consisting of characters I, meaning it's an increasing part of the string. D means decreasing, right? A zero indexed string num of length n plus 1 is created using the following conditions. Now nums consist of digits from 1 to n, where each digit is used at most once, and if pattern of I equals to I, then nums of I is less than nums of I plus 1, or if pattern of I is D, then nums of I is greater than nums of I plus 1, right? Return the lexicographically smallest possible string num that meets the condition. uh, let's look into the two examples. I'll take the easy one first, right? I'll take the easy one. So the example 2 is ddd, right? So I need to construct. So what does ddd mean? Ddd means that you have a string of length 4. The pattern length is 3, the string length is 4, obviously n plus 1. Here d means that uh, these two values, if I compare these two values, then basically these will be in decreasing order, meaning that if this is I, this is j, then I is greater than j, right? If it would have been I, that means I is less than j. We are going increasing order, here we are going in decreasing order, right? So these are the two things. Now what does ddd mean, right? So that means we have a string of length 4 where the characters are in decreasing order, all the digits are in decreasing order. So what could be a possible value? It could be 9 5 4 3. This is valid, right? What about 9 8 7 6? This is also valid. What about 4 3 2 1, right? These all are valid, these all are satisfying this condition, but we need to return the lexicographically smallest possible string. So this will be my answer, because you cannot form a string smaller than this one of length 4, which is following ddd, right? Also you can use each digit only once. Otherwise what we would have done, we would have made it one, or like for example, again, since it's ddd, not possible here, but basically you can use every digit only once. So that's why it is 4 3 2 1, right? Let's come to the second example. So the second example is, if I just draw a line, so it is I D D D, right? Now here it's a obviously it's a bigger string. So what will happen here? The answer in this case is 1 2 3 5 4 9 8 7 6. Let me take some simpler examples. Suppose I, right? So that means the length is 4, 1 2 3 4, and I need to find the smallest string that satisfies this condition. So what is the smallest string? 1 2 3 4, right? What are the other possible values? It could have been 1 4 6 8 as well, but this is the smallest one, so I return this, right? If I talk about id, right? id, so what will happen? A length of 3, right, where first it is increasing and then it is decreasing. I can make here 1, I can make here 2, right? Now I want a decreasing number. So just see here, a decreasing number, if I put a decreasing number from 2, it will be 1, but this number will be repeated, right? So I cannot take this one. What is the other option, right? If I start with 2, so it goes to 3 and it becomes 1. Now is it the smallest one? Yes, because you are bound to keep 2 here, because if you keep 1 here, then or another possible option is, if you keep 1 here, so it is 1 3 2. This is also possible, right? This is also possible. 1, then increasing 3, and then 2, right? So these are the two possible things. Now you just choose the lexicographically smallest one, which is this one, and then we are good to go, right? So this is what the problem is saying. Now what I have done is, or rather what we can do is, that it is given that the pattern length, the length of the pattern that is given, that I D D something like this, it can go up to 8. What does this mean? That the length of the string that I can have can go up to 9, right? This is the only possible thing. Now the total number of possibilities that I can have, that I can generate for the given condition, what are those conditions? That the length of the string is this one, n plus 1, where n is the length of the pattern, and every digit is used only once. So that means, don't you think that will be equal to, in this case for example, it will be 9 factorial, or here it will be n plus 1 factorial, right? Because suppose I have two digits, or let's suppose I have three digits, I have three places. So and I can use a digit only once. So how many possibilities do I have here? I have three. If I am taking 1 2 3, I have here two possibilities, and I have here one possibility. So that means it is 6. So that is basically 3 factorial. It says that how many ways are there where you can basically form an arrangement where each digit is used only once. You need to rearrange them. So that is basically 3 factorial, the length of the string factorial of that, right? So this is my answer. Now what we can do, we can generate the again, since the constraints were less and I wanted to code it fast, so what I did, I generated all the permutations. And then finally, after one permutation was generated, I just made a utility function which used to check whether the pattern that is given, so the current permutation, whether that is satisfying that particular pattern or not, right? That is what I did. Now calculating the permutations is a different problem, but still I'll just give you a brief overview how we calculate the permutation. However, that is a topic of a totally different video, or you can refer any resources of how to calculate the permutation. Let me just show you how I calculated the permutations, right? So also there was one more thing what I did again. You can just call it a hack or something like that. So a total what is the string that I can start with, right? I can have a total of 9 characters. So what I did, I calculated or rather I would say, if the length is 5, so I took the first 6 characters, because I can use only these characters to form my string, right? The smallest string. So if length is equals to 5, the length of the string will be equals to 6. So I took the first 6 characters and then calculated the permutation of this one. This was just one of the thing, no hack basically, but yeah, take the first 6 characters. So if you need the first n characters, so take the first n characters from this string, or take the first 10 digits, right? Let's jump into the solution. On line number 46, I've initialized my string with 1 to 9. This is so that based on the length, you can just take that particular substring. Now again, a couple of attributes, this dot pattern equals to pattern, this dot length equals to pattern dot length. I've done this so that the utility function doesn't compute it every time, and I do not need to pass it to that function. That was the main reason. And on line number 49, I've called the permutation function, where you can see I've passed the str dot substring 0 to length plus 1. That means I've passed a substring of length plus 1, and then I'm computing the permutations for that. And 0 is basically represents the current index. Now on line number 50, what I do, I generate the answer and I return a substring of 0 to length plus 1. Actually that is now that is not required. Initially I was doing some other stuff, that is why, but yeah, that can be made something like what I can do, I can just return the answer only, right? I'll just update it, but this solution would work. Now you go to the permutation function on line number 27. You have passed the characters, the n characters, and the current index is 0, right? So what you do on line number 36, skip line number 28 to 35. For on line number 36, what I do, I just traverse the characters that I have. I equals to current index, I less than chars dot length, I plus first. Now while generating the permutation, what you do, if you are at the current index, so you swap it with the other possible characters that you have, right? Other possible characters. So on line number 38, we have swapped the 2 characters. What are the 2 characters? The first, I'm considering the current index, and with which characters can I swap it? It is basically current index to chars dot length. Just basic stuff of how to calculate the permutation, and then you call the permutation. Now again, you swap the 2 characters that you swapped on line number 38. You do that again on line number 40. Why you do this? You do this so that the order that you are having while this function was called, while this particular instance was called, so after you leave this loop, after you leave this particular instance of the function call, you basically get the same, you do not change the state of the chars. That's the main reason, because you need to generate all the possible strings, right? So on line number 38, you have swapped 2 characters, you have computed whatever you wanted to compute. Now again you are swapping those two characters so that they again go to the initial position which you got while this function was called, right? Now what I have done, on line number 28 to 35, we check if the current index is equals to chars dot length minus 1. That means you have generated all the characters, so call a function is valid permutation. I'll show what is there. And if answer dot compare to, again, if so answer is a variable that I have taken. If I compare it with the, if this is a valid permutation, and if I compare it with the answer that I already have, and if answer is large, lexicographically large, so I update my answer. That's the main logic. Let's come to the is valid permutation function. So again, nothing fancy here. On line number 6, you can see. On line number 7, I have taken a variable d, which basically represents that the current for particular I, is this a increasing sequence or a decreasing sequence, right? So I've traversed the pattern and the permutation that I've generated. So if the character as I plus 1 is greater than I, so that means the sequence is increasing, else it is decreasing. On line number 14, I have checked that if the current sequence in the permutation is equals to, or if it is not equals to the expectation that you have in the pattern, right? If the current index at pattern says it should be an increasing sequence, but the permutation for the current index says that it is a decreasing sequence, right? So you return false. Else you come out of the loop after the iteration is complete, and you just return true. So this is what I've done. And again, as I told you, on line number 50, I can remove the substring part and then also it will work. I did this because I was doing some other stuff in the first go while I was writing the code. So you can just return the answer, no need of substring and all. Actually, yeah, because on line number 4, you can see now I have initialized it with 99999. If I initialize my answer with the nines, the number of 9 should be equal to the length plus 1, right? As we have seen on line number 49. So if the pattern length is length, then if I initialize my answer with the length plus 1 nines, then I don't need to calculate the substring. Here I have calculated because I have initialized my answer with more number of nines, irrespective of how many characters do I need, right? So you can update the answer variable on line number 4 and skip and remove the substring part from line number 50. In this case, you will need it, right? So I hope the logic for this one is clear. Generate the permutation, and once a permutation is generated, just check whether that is a valid permutation or not. That, yeah, I would say sort of applied a brute force, because in this case, again, n factorial would work, and hence I've done this thing, right? Yeah, I hope you learned something new from this video. Please do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, please do mention that into the comments. I'll try to resolve each one of them. Thank you. Take care. Bye bye.